Hello, this is Nick, and in the previous video on these videos about physical science, and the previous one we spoke about the conditions, the necessary conditions for proportionality, and we discussed the fact that it must be a straight line, and that straight line must pass through the origin, which will have the coordinates 0, 0. Okay. In this video, we're now going to look at the conditions that are necessary for inverse proportionality. As the conditions that are necessary for inverse proportionality. Alright, so for inverse proportionality, you must have a constant when you multiply the x value times the y value. So you can get any two corresponding values for x and y, and when you multiply them, they should come out to be the same number, which would be a constant. So that's one of the conditions of inverse proportionality. For example, the time it takes to complete an activity is usually a good example of an inverse proportionality, because whatever you do, with time, if you increase the number of individuals doing it, the time decreases. So, for example, the time it takes for an increased number of workers to complete the assembling of a car, when the number of people increase, then the time it takes for for them to complete the assembling of a car would decrease. So that's an example of an inverse proportionality or inverse proportion. So here we have an example. The number of workers will increase from 20, and it doubles. It doubles every time it increases. So it doubles from 20 to 40, 40 to 80, then 80 to 160, then 160 to 320. At the same time, the number of hours taken would decrease. It goes from 10 hours to 5 hours to 2.5 hours to 1.25 hours to 1.625 hours. And notice that when you multiply those two numbers, you always end up with the product. In this case, is 200. That number that you get, the number that you get when you multiply both of them together, that constant that you get is actually the slope, right? That would be the slope. And of course, the slope is also known as the gradient. It can be represented by k, it can be represented by m. So that would be the gradient or the slope of the curve. Also, the resulting diagram or position is represented by a curve. It's represented by a curve, not a straight line. You're not going to get a straight line in an inverse proportionality unless you do some manipulation, which I will discuss in a few minutes. But even that manipulation would not be an inverse proportionality. It would be converted to a proportionality straight line. All right. But in this case, it would be a curve, and so here's the example. This is how it will look, which is y is equal to k over x. See, so the red dotted line would indicate that the slope is in a negative direction, which is really the opposite direction, meaning that it's going down. And and this is the opposite. This is opposite to a proportional line, in which case is going up and it is a straight line. Alright, so inverse proportionality means that you're multiplying by 1 over k times x. So you're actually multiplying by 1 over k. Alright, so y is equal to k times x. That's a proportional relationship. Y is equal to 1 over xk, 1 over k. Actually, it's k over x. It should be k over x. That's what is inversely proportional. Y is equal to k over x. Let me just change that. Yeah, so y is equal to k over x. That is inversely proportional. Y is equal to k times x. That is direct proportionality. All right. So in physics, there's generally a need to manipulate the formula in order to get that inverse proportionality to be turned into a proportionality. All right. In other words, they're trying to see if you can change that curve negative slope into a straight line, which is a positive slope, and also a slope that goes through the coordinates of 0 and 0, which is the origin. This means that you might end up using a different formula. In other words, you're not using the formula y is equal to k over x, right? Because that would create a curve with a negative slope. Now, it's important to note that you're not changing the data. You're using the same data, that you collected for the inverse proportionality, but you're changing the formula. You're creating a new formula, and that formula would cause the production of a, a direct relationship, in a positive, with a positive slope. All right. So you're not changing the data. You're not changing the data. You're just manipulating the formula to represent the data to create a straight line. In many cases, for example, multiplying by 1 over x squared, meaning k over x squared, or k over x cubed would result in a straight line graph going through the origin. So generally, that could be a solution. So this would cause this inverse proportionality to look like this, to look like this inverse proportionality with the same data, with the same data. All right. So that's it for this these conditions of producing improportional um, an inverse proportionality. And the next video, I will be talking about the distribution of the coordinates on a graph, and this will help to lay some form of foundation for future videos in this series. Again, this is Nick. Thank you.